Okay, hi everyone. Can you hear me? So my name is Keiko Chitose, an executive board member of WinGlover, currently working at the Nuclear Energy Agency. I'm delighted to warmly welcome all of you to this webinar. First, let me briefly introduce WinNexi. I will go to. I hope you can see the next page. So as you can see, the WinNexi was established in 2023. Our members collaborate to promote interest in experimental work by sharing best practices across different fields. I myself and Ms. Safa Youssef Abdo are now leading this group, and we have around 7 members. This is our second webinar in 2025. And before we begin, I'd like to outline today's sequence. Unfortunately, Ms. Kawano will not be able to join this webinar. I will moderate this session, and I will introduce 4 professors, and they will give their presentations for approximately 30 minutes. Please submit your questions in the chat or the Q&A section of the Zoom screen during the presentation. After that, we will have Q&A session. Then we plan to close the webinar by 13:40 Central European Time. Now, I'm very pleased to introduce today's speakers. First one is Professor Izumi Nakamura and Professor Yukiko Okada, former Commissioner of Atomic Energy Commission of Japan, and Professor Isamu Sato, and Professor Naoto Hagura. So now the time is 1 o'clock in Central European Time. So I will stop sharing. And Professor Nakamura, the floor is yours.
Thank you, Keiko. Can you see my screen?
Yes,
Oh,
we can
okay,
see.
thank you. So let me start my presentation. Thank you, Keiko, and thank you all for coming to this webinar. I'm very, wait a moment. Uh, wait a moment. Sorry. I'm very pleased to have this seminar, to speak to you today. So let me introduce myself before I start my presentation. My name is Izumi Nakamura and I work as a professor at Tokyo City University from 2021. My research area is seismic engineering, and my recent research topics are ultimate behavior of piping systems under severe seismic input. And based on the knowledge from the ultimate behavior of piping systems, I'm now concerned on developing a seismic design procedure that accounts for the elastic behavior of piping systems. And other research interests recently I have is numerical studies on floating structures under seismic loads. I usually conduct experiments on structure models, and recently we have installed a new equipment in our laboratory. So today I'd like to introduce it along with other characteristic equipment in our research laboratory. So let me start. Sorry. So this is today's content. First, I will introduce our university and the Atomic Energy Research Laboratory at Tokyo City University. And then I will explain the current experiment facilities in our laboratory. And finally, I will briefly touch on the contribution to education and outreach activity. So let me start my presentation. And at first, I'd like to introduce our university and our research laboratory. At the beginning, I'd like to provide a brief introduction of our university. Tokyo City University is a private university in Tokyo, and it was established as a engineering school in 1929 and to reorganize to Musashi Institute of Technology in 1949. And in 2009, Musashi Institute of Technology incorporates other college and renamed to Tokyo City University. There are 8 facilities in total in our university, and I belong to the Department of Nuclear Safety Engineering, which is one of the departments in the Faculty of Science and Engineering. And our university has the Atomic Energy Research Laboratory in Kawasaki, near Tokyo, as one of the research facilities in our university. This research facility was established in 1960 for the peaceful use and technological development of nuclear energy. This is a brief history of the Atomic Energy Research Laboratory at Tokyo City University. The first criticality of reactor was achieved in 1963, and since then we have conducted several research activities such as material irradiation test, neutron activation analysis, and medical experiments. One distinctive research activity at our facility is BNCT, boron neutron capture therapy, and I will explain it in the later slide in more detail. And in 1989, the plant was forced to shut down due to a slight water leak from the reactor core, and restarting the plant was not easy due to strong protests from nearby residents, and the Chernobyl accident occurred on that age. And in 2003, a decision was made to decommission the reactor, and a few years later, the fuel was handed over to the US DOE. So, although the reactor is awaiting full-scale decommissioning, the research facility is still active. We can handle RI, and small accelerators have been installed in recent years, and researches using the equipment are being conducted in various fields of nuclear power generation and radiation utilization. So I will introduce such current facilities in this presentation. I'd like to provide the current status of our facility in this slide. The facility is being decommissioning in stages. The first step is to permanently shut down reactor operations and remove the spent fuel from the facility. And in the second phase, the radioactive waste and related materials are stored and managed on site. In the third stage, we plan to remove radioactive waste from the site. And the current situation at our lab facility corresponds to phase 2. And another feature I'd like to mention is that the facility serves as an inter-university research facility, which means the facility is jointly used by universities. To utilize the research reactor under this framework, a part of the nuclear reactor equipment was converted into a neutron irradiation chamber, and the facility was used for research on the treatment of brain tumors using boron neutron capture therapy. The treatment results are as shown here. about 100 cases for brain tumors and 9 cases for skin cancer. Because our laboratory is not a medical facility, the therapy was treated as a medical experiment. And a lot of medical experts came to the laboratory when the therapy was conducted. And I have heard that the facility staff, especially women staffers, face many difficulties in supporting the therapy. And these are the history of our laboratory. And then let me turn to our current experimental facilities. There are several experimental facilities in our laboratory now actively used. First, I'd like to introduce the experimental facility related to seismic engineering, which is my area of expertise. As I introduced myself in the beginning of the presentation, my research interest is seismic performance evaluation of piping systems and equipment in nuclear power plant. And the main research methods I usually use are shaking table experiments and FEM analysis. And I think most of you are not familiar with shaking table. And what is a shaking table? I will explain here. Shaking table is a device that applies controlled vibration to structure models to investigate their dynamic behavior. And there are many types of shaking table, and they are used for a wide range of purposes, from verifying the seismic performance of large-scale structures to testing more small mechanical components. And shaking direction is one directional or two direction or three direction depending on the system. And before I joined the university in 2021, I worked at the National Research Institute that had the world's largest shaking table, shown here. And I have conducted many types of large-scale shaking table tests, mainly on piping system models in my previous employment. These photos show such experiments. This is very, very huge experiment in on almost actual size of specimen. However, such large-scale experiments cannot be conducted frequently due to limitations in budget, manpower, and available facilities. And mainly, budget problem is the most important. So, in order to conduct related research on seismic engineering, a small shaking table is useful for investigation of fundamental behavior of structures. So I tried to set up a small shaking table at the Atomic Energy Research Laboratory. And it has been realized this year. This is a new one-directional shaking table installed in the Atomic Energy Research Laboratory this year. This shaking table is very small compared to the shaking table I have used in my previous employment. For example, table size is just 800 millimeter by 600 millimeter, and the shaking direction is only one direction. It moves only this direction. However, such a small shaking table is useful for investigating the fundamental dynamic behavior of structures. And I'd like to show an example of shaking table here. Wait a moment. Unfortunately, I think that you cannot hear any sounds, but please see the video. This is an example of shaking table. I will start again. Wait a moment. Uh, this is an example of a shaking table test. This is only small specimen, but it can, how say, reproduce the dynamic behavior of structures. And in this experiment, we reproduce the failure behavior of piping support in uh, in in how say brief way. And this is I'm planning to conduct experiments on cylindrical shell or piping system and so on from this year. And then let me move on to other facilities in our laboratory. This is a 1.7 megawatt Peltron tandem accelerator. It was introduced as a new experimental apparatus replacing the reactor in 2018. And we conduct elemental analysis and evaluation experiments using ion beam techniques. The research using this equipment is mainly conducted by Hagura sensei in the laboratory. And we also conduct radioactivity analysis using germanium semiconductor detectors. And neutron activation analysis was performed on objects such as high purity materials and archaeological materials. And one feature that I should mention is that since the Fukushima Daiichi nuclear power plant accident in 2011, we have focused on measuring environmental radiation in Fukushima and the surrounding prefectures. And Sato sensei, Hagura sensei, and Matsuda sensei, who is unfortunately absent today, use this equipment. And this equipment is also used by researchers from other universities. And this is the third research instrument in our laboratory. We have a glove box which is used for the research on the nuclear fuel cycle. This facility enables sample preparation in molten salt conditions as part of research on the nuclear fuel cycle. And this equipment is mainly used by Matsuda sensei. Unfortunately, he is absent today. And this is a cold laboratory in our research laboratory. Cold means non-radioactive materials. And sample preparation and analysis using non-radioactive materials are conducted here. And in the cold laboratory, we use these tools to investigate the to conduct the researches on catalysis function of platinum group fission products, dynamics of fission products absorbed on absorbent materials during heating, and so on. And these are the tools to investigate such target materials and the tools used in the cold laboratory. And these equipments are used by Sato sensei and Matsuda sensei and other researchers using this facility. And we also have a reactor simulator in our laboratory because we have operate we had actual research reactor in our laboratory. Control panels actually used during operation are employed as educational simulators, as shown in these photos. And you can observe the movement of the control rod drive mechanism while viewing the simulator reactor core up close. And finally, Let me introduce our contribution to education and outreach activity. Using, as I introduced many research equipment in previous slide, such equipments are utilized for educational purpose. Using these facilities, we conduct experimental training programs for undergraduate and graduate students. These programs involve hands-on training using radioactive isotopes, reactor simulators, tandem accelerators, and other equipment. These photos show our students learning the fundamentals of nuclear engineering using the equipment I have introduced. Oh, sorry. And we also place strong emphasis on outreach activities. We hold an annual facility open house event to introduce our facilities to local residents and junior high and high school students, as shown in these photos. And many students or local residents visit our laboratory, like these photos. And we also accept tours upon request. We continue to make efforts to build good relationship with local residents and younger generations, like this. So I think it's very, my presentation is a little bit short, but I'd like to summarize my presentation. Tokyo City University established the Atomic Energy Research Laboratory in 1960 and operated a small research reactor. Although the reactor is currently undergoing decommissioning, the laboratory continues to use other specialized experimental facilities such as shaking table, a tandem accelerator, a glove box to support its educational and research activities. We hope this very brief introduction, but we hope this introduction has given you an overview of our facilities, and we would be delighted to welcome you to our laboratory whenever the opportunity arises. So this is very short presentation, but thank you for your attention.
Thank you very much, Izumi. And I think one raise hand on the screen, so I think participant can unmute by themselves and make a question verbally. So, so sorry, my bad pronunciation. Bahia Gargote. Are you raising hand? So I cannot pronounce your name correctly, but are you raising hand? Bahia girl from Turkey. Do you have any question? Okay. Yes, and so far we don't receive any questions on the question and answer section or chat. So if you have any question, please raise your hand or so if you need some time to think about the question. So I have a few questions to all professors. So first of all, very basic question. So how many staff members does the laboratory currently have?
Sato Sensei, could you answer that?
はい。 I'm Isam Sato. So number of the employee in this laboratory is only 5%. But
Wow.
most of the person so have double role. So I so five persons, only 5 person, but other 5 persons ダブルなんだ兼務兼務って何でしたっけ
Double assignment.
double assignment to department and laboratory. So, but normally 5 person in the laboratory. Okay.
Okay, thank you very much. And I've noticed that girl cannot open the voices. Oh, okay. Yes, and then she provided a question by chat, a Q&A answer. So I would like to ask if any new research reactor is planning to be installed at the university for more detailed research. Do you have any new research reactor plan?
I think it is very difficult, especially in Japan. How do you think, Sato Sensei?
Yes, so it is difficult to to make the new reactor because around here, so there is a lot of residents. But ancient 50 years ago, so there is no residence. But so increase of the people and around here. So I think it is greatly difficult to make a new reactor.
Thank you very much for your answer. Yes, in Japan it is very difficult, but maybe we need some international collaboration to share the research reactor together. That is the option for all of us. And then we have another question. Do you have any research related to radiation biology or radiopharmaceuticals? So,
Yes, researcher in this laboratory is not so directly to the medical activity, but so in our department there is a researcher to make research about radioactive medical. So name is Takagi Sensei, Takagi, Professor Takagi.
okay, thank you very much. So your university have some kind of activity related to radiopharmaceuticals or radiation biology. Okay, so is there any other question? Yes, okay, so the following question from the first questions. So maybe you can read it, but I will repeat it. You mean due to anti-nuclear reactions from local people. On the other hand, after Fukushima, more safety research needs to be done at the universities. So how about your thoughts or opinions?
Thank you for your question. And actually, there are, how say, how say, somewhat against atmosphere for the nuclear power plant in Japan. Of course, it is a little bit improved recently, but not so, how to say, there are atmosphere against the nuclear power plant. But as you pointed out, the more safety research is needed to be done, and we conduct many research to improve the nuclear safety in university. Is that did I answer to your question? And Sato sensei or Hagura sensei, if you have any words to this answer, please provide your answer.
I think so also. So yes, so it is improved a little, I think, but so not so great. Just only a little bit change to nuclear industry.
Thank you very much. And Hagura sensei, do you have additional thought?
No.
So
I agree
everything
with you.
covered. Okay.
Yeah.
Okay. Thank you very much. Thank you very much. And is there any other question or comment from the audience? So if not, and we still have some time, so maybe so any equipment of your laboratory is okay, but is there any challenges during the installation of this equipment to your facilities? Please tell us about both technical challenges and also kind of procedural aspects or some regulatory compliance aspect. If you have something, please share with us.
Talking about accelerator.
Any type of equipment is okay. So Sato sensei, please talk. Professor Sato, please talk about your facility or accelerator.
So if we want to know the accelerator, so we ask the Hagura sensei better. So 導入時の辛い思い出を話してください。
Yes, one of the main challenges was that we did not have in-house specialists in accelerator engineering. We were supported throughout the process by many experienced professionals, and we truly appreciate their support.
So mainly from Tokyo Science University, the professor.
Yes.
Thank you very much. And are there any other challenges? Do you want and then you got enough support from other universities. That is very good experience. And maybe yes, please go ahead.
So we have a very great issue on this laboratory because the laboratory is very old. So electrical infrastructure is very weak. So if we install the new machine device, so these devices need to electricity, a very big electricity. But so all infrastructure not match the new big device. So if so install this device, so we have to make to prepare the electricity infrastructure system. So very high cost. So when Nakamura Sensei installed the shaking machine, so we had to prepare the electricity issue.
Thank you very much for sharing your experiences. So we need more electricity or more modern system to install new one. So, and also the aging issue is almost everywhere. Okay, and then maybe this is maybe the last question if there is no. So do your laboratory conduct joint project with overseas universities, or are there any plan to collaboration with other countries' institute or university? Maybe Wing Global member want to know
Yes,
that part.
welcome, very welcome. I want to connect the other university or institute because it is very make our motivation. So we want.
And I think your laboratory or your faculty wide, you have several foreign students now studying with Japanese students, right?
Yes,
So
yes.
that
There are few exchange students from mainly China now studying in the atomic energy research laboratory. So we are open to 4-person. So we are open to overseas, and we are welcome to have make a joint research if any chance.
Thank you very much. And so, yes, please.
Radiation biology field, no person research on this field. So
so radiation biology is not yet.
But no. There is Okada Sensei. Okada Sensei. So Okada Sensei researched on the radiation biology. So what it is, so cesium dynamics on the in the lake. So I think it is related to the radiation biology, maybe.
Yes, so.
岡田先生、いいですか、それで。
Yes, so you have a specialist in your university and very important part. Thank you very much for. Okay, is it okay? So maybe there is no additional question or comment. So we want to conclude this session. So thank you very much for all presenters for you and professors providing comprehensive and outstanding presentations and to all participants for engaging and insightful discussions. And we look forward to keeping you informed about upcoming Win Global events through Win Global channel. So wishing you all the best, very best until we meet again. So goodbye, everyone. Thank you for coming. Bye-bye.
Thank you.